Yeah, I do. The sound's okay, right? Okay, very good. Thank you. You can confirm that, Richard?
Sounds good.
All right, super. Okay, so welcome to Grease Thief Thursdays. I'm Rich Wurzbach, and today I'm going to do kind of an impromptu off our schedule a little bit. We were talking about doing something with wind turbines, which is a topic that we're going to circle back to in a couple of weeks. We're looking forward to that. It's going to be real exciting. It's going to be a combination with the folks at Poseidon Systems who work with online sensors and are very heavily involved in the wind segment there. So we're going to take a look with them at the technology that allows us to look at ferrous content in greases, the FerroQ instrument, and just in general talk about how we take samples and analyze greases effectively for monitoring wind turbine assets. But today I'm going to go back to the fundamentals. We're going to talk about sampling, and we're going to use as our example today our simplest kit, simplest designed kit, and that's going to be the Grease Thief Pillow Block kit. And this is a kit that's really versatile. It has a lot of components here that allow us to not only be optimized for taking samples from pillow block bearings themselves, but also other applications as well. So when we have folks that are just getting started in grease analysis, we'll often, encourage them to, start with that. And this is the sleeve that you're going to find in the pillow block kit. I'm going to be talking about this and demonstrating this in a moment. And then we'll, take some samples from a pillow block test stand that I've set up here on my desk today. And then we'll also see what we could do just as some initial inspection in the field to look at the grease sample that we've taken, as well as discuss what we could do to analyze that out in the, back in the laboratory or in a mini lab or something like that. So I'm going to share my screen here. I do have some materials that we can start with here to put to give us some background. And so I'm going to put this PowerPoint presentation up and start just by talking about some of the applications. So where is grease analysis being used today? And the industries, the applications, the assets include pharmaceutical manufacturing and research, which is obviously a high profile, extremely important industry to us globally right now in our efforts to address some of the issues around the COVID with the development of vaccines and the distribution of those vaccines and making them available around the world. And part of our history of that really started at the National Institutes of Health here in the U.S., where we got involved in monitoring HVAC equipment that was grease lubricated in an effort to go beyond just the kind of vibration analysis to say, yeah, there's some bearing damage here, or infrared to look at heating. We wanted to understand better, what was causing issues related to grease lubricated bearing failures that were impacting critical research in that environment. And a lot of the things we learned there are directly applicable to pharmaceutical manufacturing. And so this kit that you see here was first deployed at the National Institutes of Health to take those samples, to take pillow block samples from critical exhaust fans and air handling units supporting biomedical research. And so that's got great applicability in pharmaceutical manufacturing as well. Robots, another great application, slightly different kit being used there. A lot of the robots being deployed in automotive manufacturing applications. Wind turbine samples, we'll talk about that in a few weeks, the main blade generator bearing samples there. In that case, the main bearings often are very similar, or by design are very similar to pillow blocks, just really big pillow block bearings. And one of the applications for wind turbine sampling is basically to use the same sleeve that I just showed you, the same components, in that wind turbine to sample main bearings, just using a slightly different technique to get that representative sample. So it's almost like a big pillow block kit when you come down to it. Electric motors in many applications, motor operated valves. I'm going to schedule one in the coming weeks to take another look at motor operated valves and how we get good grease samples there and how that can help us operate those assets. Marine applications like cranes, some shipboard applications, but definitely like container handling, cranes and that sort of thing. Great opportunity for grease analysis. And sometimes those large slewing bearings are best collected with this pillow block bearing sample kit. Military applications, we've done some work in helicopters using a slightly modified version of this, and I'll kind of point that out as I demonstrate the components. Food grade lubricant management and food processing, another great application. And then we've seen more interest in quality control of new greases, so we can look at particles and look at moisture levels and consistency of grease using some of these techniques. So the samplers that we use that you may be familiar with, may have seen before, you've got the grease thief picture there on the left. That's the style of grease thief we're going to see in the pillow block kits. There's a second style that you see pictured to the right that has the stinger probe on it. And we'll talk about that in reference to sampling enclosed spaces like gearboxes and certain large motors where we're sort of sampling blind and we need to be able to position that grease thief to core that representative sample at a location very adjacent to a surface. And so that stinger probe helps us kind of tactily feel that we've entered that far into the enclosure of the machine to get that sample. But the one on the left, the type 1 without that is what we're going to use. There's also grease thief slim for smaller openings when we need to get into an enclosure, but we can't quite fit a grease thief in there. We've got the grease thief slim. So here are these 6 different kits, and of course today we're gonna focus in on this pillow block kit. We're gonna look at what we have in there. Well, that didn't work. That kind of let's see, that helps. No. Okay, but anyway, that's the kit we're looking at, which is the pillow block kit. And it is going to have these 8 sleeves in there. It's going to have the grease thief. It's going to have a spatula, and we'll show you how to use that, as well as a syringe that helps us transfer the grease into the grease thief. We have this guidance document, this flow chart, which helps us help someone choose what is the right sampling kit. We showed you 6 different kits there. So there's different applications and so forth. And either this flow chart can be helpful in choosing the right tools for that application. And all of this is really captured in that ASTM standard, ASTM D7718, which is out there as a standard kind of a reference to take good samples of grease from in-service equipment. And you can see we start by asking that question: what's the desired sampling application? What kind of equipment are we looking at? What kind of access do we have to it? And at the end of this process, as you go through these questions, you end up with different kits being specified for that application. But you've got this all the way here to the left, the pillow block kit. We call that kit number 8 or kit 008. And you can see it's leading you from pillow block bearings, which could be in fans, conveyors, could be open bearings, or you could have other unknown or general applications are both going to take you into this pillow block kit, as well as sampling electric motor bearings. If it asks if it's kind of routinely relubricated with an accessible drain plug, if it is, we've got the kit that's really just gives you that grease thief. You thread it into the machine, you let it sit there, and when the grease comes out, you capture it. But if that's not the case and you have to go in after the grease, the pillow block kit might be a good solution for that as well. So you can see this process kind of walks you through, the options, and then of course there's other things like wind turbines, motor operated valves, robots, and so forth, to get you to the right tools and the right technique to get a representative sample. And of course, once you have it, that sample can be evaluated with a number of instruments, including the ferroQ for ferrous debris, to do dye extrusion with a grease thief analyzer, to do colorimetry with the grease thief colorimeter. And I'm going to show you kind of a shortcut, kind of in the field colorimetry for greases. It's not as numerically significant. You can't create criteria, but sometimes it's just a quick check of color that you can do in the field, and I'll share that with you today. And then we just kind of show some of the other techniques for analysis here. We process this all through a system we call Navigator, and why that's helpful is that it allows us to kind of aggregate samples from different locations, different customers, but in similar applications, so that we know what's normal, what's typical, what would be considered an outlier value. And that helps us really with the screening process, where we can screen through a lot of samples, kind of put them together and group them together, and then find those outliers in data sets. So you see that here off to the right with some wear concentrations. You can see these various groupings here, some of them in the green because the numbers are real low ferrous wear content. But then in other cases, you've got significantly higher values on this logarithmic chart. So when you see that, you can kind of group them together, call them out for further analysis, and then do some investigation. Why, is this particular data set so much higher than wear levels in other locations? And then, looking at the consistency values that you see below, we kind of want our consistency to remain close to what it was when it went into the machine as new. Sometimes it gets a little softer after working, or could even get a little harder depending on the circumstances and contaminants that are present and so forth. But we don't want it to change too much, because that property, that consistency property of the grease, helps it stay in place, but also allows it to move and continue to feed the required oil and additives into that application. So that's another thing that we can check and screen for when we get these samples. So, this is, with this presentation today, talking about pillow block bearings, this is what we're trying to avoid. We're trying to avoid this kind of predictable failure, and the kind of failure that, if we're doing grease analysis, we can better understand what led to that failure, what caused it. And once we understand cause or root cause, then we can change our practices to avoid that happening in the future. And I did talk about this, this whole pillow block sampling starting at NIH. And, this is one of those bearings that I was involved in, trying to figure out what happened here. Initial call on this was the bearing rusted out. The folks that responded to this failure of this fan saw red dust everywhere. You can still see it there on the surface of the bearing, and thought this was some kind of rusting mechanism. But when we did get the grease sample and analyzed it, and we were able to look at what was there from an IR perspective, from a color perspective, and just the constituents in that grease, it became clear this was a grease mixing problem. And this is where the kit came into play for us. Okay, so because you can, once you've got a bearing wide open like this, you can grab what's there. It's accessible. You could use a tongue depressor, or whatever you have handy that's clean to get some of the grease off of that surface. But what about when it's still in the machine? What about when the machine is still running or operating? And that's where we need some other tools that help us get safely get a sample that's going to be representative and really help out. So that's what you're going to see in this kit. What we needed to do in response to this failure was to go out there and sample the other 18 bearings that were in the same application as this one here, and find out, were there other similar problems in the field just waiting to degrade like this. And so that kit allowed us to take those samples and find that a few of those 18 other bearings did also have a mixing problem, but we were able to catch them early. We're able to flush the grease out and preserve those bearings for a long period of time. And that's what it's all about with grease analysis, is finding the issues, using that to complement other tools that we have, other technologies, and then get down to the root cause and understand how we can prevent failure and really optimize the performance of the equipment and the life of the grease. So with that, I'm going to shift back here and just go ahead with a bit of a demonstration. Now I'm going to switch cameras here, and I'm going to go to my kind of close-up camera on my process here. I think. Let's see here. All right, an extra button to push there. So we're looking head on here at the end of a pillow block bearing. And this one's just in a test stand where it's a single pillow block bearing, have a small electric motor to run this. And we use this from a training perspective. We use this to do some testing, to evaluate different scenarios, and then be able to demonstrate to folks, this grease analysis process. And I'll turn this around so you can see the back side here a bit. And I'm going to reach for one of my kit sleeves. Now, for these sleeves, you'll see that they come with a seal on here, and that's perforated, so we can peel that off. But what it tells you is, right now, that is clean. Okay, so I don't have to worry about were these materials sitting at the bottom of somebody's toolbox? Were they sitting out exposed? Had they been in contact with other materials? These are clean surfaces, and that's really important in the sampling process, that we're able to start with zero basically and have confidence that what we end up with the sample in the grease thief in this case is going to be representative of what's in that machine. So this is my starting point. Now I turned this around for you so that you can see, and I just peel that layer off the top there. And now I can open up the Ziploc. But I turn this around so you can see what's going on the back end of this bearing. And this type of pillow block is quite typical, that you've got access to the face of the bearing. Okay. Not always. Sometimes you're going to have more of an enclosure here or some kind of shielding, but typically you've got, your Zerk fitting up here where the grease is going to enter. This is a double row type of arrangement. The grease comes into the center, goes distributes around a ring, and then there's actually holes in that outer race that pushes grease into the center between the rows, and then it pushes out in both directions, or typically has the ability to push out in both directions. And so I'm just showing you the back end here to say, don't neglect this as a potential source of grease, because there is some grease in there. And I'll just kind of reach in a little bit and pull some of that out, and there you go. Now, what's happened since that grease got to a point where I could reach at it? Has it been a while? Because if it has, what's going to be in that sample is going to be grease that was in that bearing, plus some kind of debris that was outside of the bearing, and that's not always the best. And so this spatula that has a pointy end back here that you see, but also has this wider kind of spoon edge, is kind of nice because it allows us to go in and wipe away that outer layer of grease, okay? And then leave behind, what's behind it there is going to be grease that potentially is more representative of that bearing. So I can kind of reach in. Now there isn't as much there, but that's okay. I want that grease. I want that targeted grease. It's going to tell me the better story of what's going on inside that bearing. I don't necessarily want the dirt and debris and maybe belt dust or whatever is outside of the bearing, because I want to make the call based off of what's inside. And then when I have that, I reach back into my sleeve and I go for this syringe. So notice I'm keeping the other components inside. I'm keeping them clean, and I'm keeping them protected. And then I have my syringe, and I'm going to pull that plunger right out of the syringe, and just and kind of hold that in an orientation where I keep it protected and clean as well. Now I can take the grease that I sampled and start to put that inside. And what you're going to see is that you don't get it all off, right? There's some that's kind of captured in that curve, but I can get that off by kind of dragging it along the side of the syringe end there, and then use the back end to push it down in. And then I can go back and grab some more and continue to do that. So this is my grease capturing process. Now you might already have an observation about this grease, and that is its color. And it's almost a purplish kind of grease. So it could be from a grease that is purple. It's pretty uniform. That's another observation. And I'm also going to look then for what kind of contaminants. I see particulate. What else is observable from a visual standpoint? And again, what's visible from that grease that was hiding underneath? So I'm going to spin this back around. We'll go to the front end here to get some more grease. And right now, I've got some in there, but just kind of a chunk in there, and there's still a lot of open space. So I'm going back for more. And again, I'd like to start by wiping away that outer layer a little bit, and then get that grease that's popping out underneath. And sometimes you can accomplish this by cleaning the grease away, the old grease away, before you're ready to sample. And then maybe just adding some more into the process, adding a few pumps of grease, which will push out the fresh grease. So you may start by using this to kind of clear away all the grease you've got, right? Add a few pumps as part of a regreasing activity. Then you'll see it start to come out. In fact, I'm going to start this unit up. You might see something interesting here. I don't know if you can see that on screen, but there's actually some movement of grease, which is not altogether unusual. It depends. It just depends on how long it's been there and the temperature and the consistency of the grease. But grease does tend to move around. So I'll just shut that off so you can hear me more clearly. But it also shows us that grease is not this static medium that's just a clump that stays there. In fact, it has to get out through this, this tiny shield slot so that we can get at it, that it can purge out and so forth. But that's what it's definitely doing there. And that kind of movement gets it through that slot, but also can kind of move it around on the surface. But again, expose it to the debris that's out there. So I've got plenty of grease now. I can see that. I've got this pretty full, and it's about a little better than halfway down to this 10 milliliter marking that you get on this syringe for the grease thief. And that's going to be plenty from my experience to be able to fill up the grease thief. So the next thing I want to do is bring the grease thief out of that tube. Actually, at this point, I'm going to take the protective tube out and the grease thief, because I've got some stuff to get rid of at this point. I want to get rid of this syringe, or this spatula. But first, I'm going to cover up this syringe. I'm going to put the plunger back in there a moment. Then I'm going to get rid of my trash, essentially. So I can use my Ziploc bag to do that. Drop that down inside. Okay. Then when I'm done, I can kind of close that up and get that out of the way. Now, here's the tricky part, right? Is being able to transfer from this syringe into the grease thief. And so I want to remove my cap from the grease thief. I want to pull the piston back to the midpoint. Okay. And I'm usually a little better at this when I'm not trying to pose for the camera, but you want to keep a nice tight fit. So you got to apply some pressure of the grease thief to this syringe to get that to seal along that face. And then I'm pumping grease down in. Now you can see it's starting to fill up and it's pushing down. It's pretty full there, not too much in terms of air bubbles. And now it's going to start to move that piston back. So you can see the piston making its way back. See the hole that's right there? Oh, I got a little more pressure I need to apply. That hole that's right there is kind of the back seat. So I'm going to stop just short of that, or else it's going to come out through that little relief hole that you see right there. Now, if I pull this out, that just made a big air pocket in there. So what I need to do is, as I'm pulling it out, squeeze some more grease in. So I'm pushing in on the syringe handle or the piston as I'm withdrawing to get that filled up. Now you have this really nice and full grease, and I can put that protective cap on. Now the cap goes on just snug. You don't have to cover up all the threads for that because this is a tapered fit, and that's going to be good enough. And now that you have that sample, you're going to put that into the tubing, and this is where I would get my label. I'm going to fix a barcode label to this in a minute, kind of show you how that works. Drop that in, put the cap on. Now I've got 2 layers of protection now, okay? I've got it. Figure out how to turn off my phone while I'm doing these things. It's capped at this end. The piston is here at the other end. And then of course I've got it in this protective tube, and I've got this cap on the whole thing. So I'm well protected here from a shipping perspective. If this grease was really runny, might want to run out, but I've got 2 layers of protection to keep it together. Obviously I want to keep it in that grease thief if I can. Now in my kit, I also have, I should have showed you that earlier, but that's instruction cards. So you've got inside your kit instruction cards on how you use this, the steps you take to get a representative sample, which I just shared with you. And my barcode labels, which are here. So I've got a unique identifier barcode label. This one happens to say grease cleanliness because this came in a kit that was designed to do grease cleanliness testing. It could use this same pillow block kit to gather those samples, but I'm going to take that off and assign that unique identifier to this sample. Notice we don't, sometimes these labels will have a slot for you to put some information, maybe the person who took the sample, the date and whatnot. But what we're really looking to do is to take this unique identifier number for this sample, put that into the LIMS system, your laboratory management system, and make sure that we get all of the information there. So the way we do it in our laboratory is we give the customer access to that app that's online. They can enter this number and then enter the equipment about, or information about the equipment, where's the sample location, what kind of grease is in there, what was the date it was sampled, who was the sampling person, any observations that were taken. So all that background information that helps a lab analyze it goes directly into the database, not scribbled onto a label and then someone has to interpret what in the world does that mean, or what is that equipment number really, and we don't want to be assigning results or actions based off of incorrect data transfer. So the barcode helps us get to that point. But what can I do next with this sample? I've just successfully, by the way, taken that sample from that equipment. We want to be ready to tidy things up, and that's what we're doing with the bag here, just to keep our stuff tidied up and cleaned up. Could even put the label in here and so forth. make sure I've got a clean workspace to work with, and use a little rag for my fingers here. And what can I do with this next? So I did talk about some of the steps to sampling for observations, where we want to be looking at the condition of the grease, want to look at the condition of the equipment, and kind of factor that all in. But I said I'd share with you some kind of field observations that you can make. And to do that, I just took a little piece of paper here. I'll let you see what I'm doing here. And there's my sample. And then I also have a sample of the grease that was in the grease gun, or being used in the grease gun for this application. And this is where I can check something about the appearance of the grease. And this is going to be pretty straightforward. This red grease happens to be a very clear grease, but I take the grease thief in my hand like this. I hold it down on that surface and apply a little bit of pressure, and I drag that along that white paper. And I get a picture of the color of that grease, its appearance at a very thin extrusion. And then I take my sample, and what I should see is something similar, maybe with maybe a little bit darker because it's been aging and so forth. But I put them side by side, and in this case, it raises a bit of a concern because the color here is quite different. It does have a bit of a reddish color to it, but it looks like we observed right at the very beginning that it's more of a purple color. So then, what else is possible here? Well, what runs this fan bearing? An electric motor. So let's take the motor grease and give that a look as well. And you can see the color contribution. And if you wanted to really get fancy, like kindergarten art class, you could start mixing some stuff together and see if they get a little bit closer in appearance, and all that messy stuff you can do. It's a start, right? It's a start that we can do in the field, and at the very least say, this does not have the same appearance as the new grease that is designed for this. Maybe it's got an influence of some other materials there, and that's certainly going to raise a concern. How do we know that for sure? Well, we've got some tools available, and even if you're working in the plant and you want to try to have something more than just this, quick check on a piece of white paper like I did here, there's tools for that too. So we build the Grease Thief colorimeter. We did have an earlier presentation for Grease Thief Thursday where we set up the colorimeter and showed how in just about a minute or so you can analyze the grease color, come up with numerical values, really the spectral values for that new fresh grease, and then look at the sample and say, how does this compare? Is it just a darker version of the same color? Is it being mixed with some other color? How does that compare? And that can really help you make that kind of determination and make some criteria for that and so on. And then, there's other tests that you can do in the, as a mini lab, which could include looking at ferrous content in the grease as well, and really, try to understand what's happening with this pillow block bearing. So that's really what I wanted to focus on today, was to help you see what's in this kit. Of course, this pillow block kit is one of a number of different ones that we have, and of course, if you get this one, it would be marked with this ID number and so forth, and what you would get inside. You would get 8 of these kind of sampling sleeves. You would get instruction cards on how to use that, and then maybe an envelope to send them back in, and that sort of thing for the pillow block kit. So 8 different samples to be taken with this kit. And then you've also got the other kits, and then at the other end of the box, you've got some QR codes that allow you their PB pillow block, zoom in on that, and be able to see a video on how to take a sample. So that might be helpful. You put this in the hands of somebody out in the field, needs to go take that sample. They can pull out their smartphone, scan that, see a video like I shared with you today to know how to go through those steps to take that sample, and so on. So pillow block kits, really our basic kit, our versatile kit, our general kit that you can use for almost any application until you get specific into other things where you need different tools. Maybe you need the type with the stinger probe on it or what have you. And I just wanted to take today to show this with you all, because really all the different analysis that we talk about, at the very core of that is getting the right sample, getting a representative sample. And if we don't get that representative sample, then we're not going to have a whole lot of value in the analysis. It all starts here. It starts with good sampling. So I'm going to take a look here to see if there's any questions. Don't see anything so far, but I'll open it up. Is there any questions on what I presented here today? Okay. Richard, are you still listening in? Did you have anything to add or anything to consider for folks here today tuning in with us?
I am still here. I don't have anything particular to add right now at the moment, but looking forward to next week's Grease Thief Thursday. We'll be talking about analytical photography, and we'll have a nice live demonstration. We'll look at some slides and be able to do a live analysis, and I think that'll be really enjoyable and really valuable.
Yeah, Richard, you from historically, you have a lot of different slides with a lot of different particles there, don't you?
Yes, I have some slides that I saved up my sleeve that we'll be able to pull out for this demonstration and really be able to drive home and identify the particles. They won't be hidden in nuance. They will be prevalent and easy to identify, and I think that'll be really helpful for anybody that doesn't have a lot of microscope experience or time at doing analytical photography. That it's really drives home being able to see some big particles that have some distinctive characteristics that really get that drive home what's wrong.
Yeah, so if someone wants to look for something specific or say, hey, I've never seen this before, could they reach out to you and say, look, hey, I'm in the wind turbine industry and I've heard there's a fretting wear mechanism on blade bearings, and could you show me what fretting wear looks like? Or I've heard that when contaminants, hard abrasive contaminants get in there, they cause cutting wear, or I don't know the difference between 2-body and 3-body cutting wear. What do they look like? Is that something that they could send you a message or send us a message on that, and you would pull them out and try to address that?
Yes, I will send a message right now in the chat that's got my email, and I'll make sure I include that next week in the flyer that goes out. That if anybody has a specific particle they'd like to see, to let us know ahead of time, and we can get that and show it on the class.
And do you have anybody else joining you for that next week, Richard?
I don't think that we've had the individual confirmed, but we are hoping to have somebody from Trico join us to be able to work with that demonstration. Yes.
Yeah, I'm going to post this there is a WhatsApp chat group on analytical photography. I'm going to post that to that, see if any of the folks that are participating in that want to come and join in, and I'll extend to those folks an opportunity to give them speaking rights so they could ask, live questions, or, ask about, could you move the slide a little bit to the left, or could you change the focus? We'll put some strings on you there, Richard, if we got some folks that want to do that and kind of walk you through, because I know during COVID shutdown here, you were coming into the lab, I was working from home, and we were going back and forth, and I was kind of saying, hey, a little to the left, let's focus here, let's go back and look at that particle, did we heat treat, and so forth. And sometimes it's nice to be able to take someone with a lot of experience and kind of get in there and kind of help drive that analytical process on photography.
Yep. Agreed.
Okay. All right. Well, I want to thank the folks that visited us today. This has been recorded and posted to YouTube, and so I'll kind of put that on my LinkedIn page. And again, join us next week for analytical photography, 1 o'clock U.S. Eastern Time. Next Thursday, the following Thursday, we're lining up the wind grease analysis session that we had originally scheduled for today, and then we've got some others scheduled out beyond that. So keep tuning in to us, and we appreciate your participation, and look to see you again in a week. Take care.